I'm Benji Taylor. I work for Distil Networks. I'm the Director of Operations there. I manage everything from network ops, like normal ops, build and release, and then security ops. So do a little bit of everything at Distil. Today, I'm going to be going through CI and CD release pipelines and the way you can change them using dynamic modules. So some of the areas of focus that we're going to be dealing on today. First of all, I'm going to go through largely some of the areas of concerns that we really see in operations at Distil Networks when we're doing deployments and what we really look for in terms of how we deal with customer traffic and what our application actually does. Doing a quick overview of just static versus dynamic modules for anyone in the room not familiar. Then going through our builds, how we used to do them with static modules, and then how we do them now with dynamic. And then the same thing for upgrades, and then finally finishing up with any questions. All right, so operation concerns. So for anyone that doesn't know what Distil does, we basically proxy traffic and look for bot-like behavioral traffic and then block it. So essentially, like anyone that has website traffic, it's all going through us. So of course, if we break their site during a deployment or cause any kind of problem with that, they get extremely angry at us. Yeah. So like I said, and then on some of these deployments too, we don't actually have the ability to remove traffic. So like on our cloud, easy enough, right, to remove traffic. We just take out a load balancer out of session and then go about doing the upgrade, can check, test, do everything fine. But then on some of these private deployments, we don't control the load balancing layer or anything at that level. So we have to do it with traffic still actively running through the box. Then also control the machine hardware, which is another sometimes problem for us. Again, these machines a lot of times in these private instances are given to us. So we have to stay a lot of times within the resource confines of what the original box looked like. And over time, I mean, as we add features, different things like that, memory, all that increases for us. So it's also very hard to get customers a lot of times to go and change those said like box resources for us. So being able to like still give new features to them and that with staying in the current confines is a very important thing to us within operations at Distil. Then finally, deployment risk. So before we do any deployment onto our network, I always go through and evaluate the risk of what's going on going out into the network. So like something to a change of our logging process, not that big of a deal because it's not customer impacting, they don't really see it at all. Then something much higher risk though, like is the NGINX upgrade itself. So like, again, that's the main thing we're proxying traffic with. So us doing any type of upgrade to it while live traffic's flowing through it is extremely, can be extremely problematic, and I consider it a very high risk operation. So now you kind of have some ideas of like what I'm really concerned about in operations, and I'm going to talk through how that dynamic modules really help some of those concerns when I do deployments in that. But first, let's look at static versus dynamic modules. So as everyone knows, static modules, the original ways that modules work within NGINX up to a certain point, all built in the main binary, and then they're all loaded by NGINX all the time. So even if you're not using them, they're still being loaded, still consuming some resource. Dynamic modules, as we've been talking about the conference, they were released this year in 1.9.11, built alongside the main binary, individual.so files instead, and then you can load whichever modules that you want over time. So again, as I said, you can load the modules that you want over time. So this is the first area that really piqued my interest when we first started talking about this, because it allows us to very much keep within those resource confines that we often have. So a lot of our features, they're all just modules within NGINX that we utilize can turn on and off. Well, we couldn't originally, but now we can. So yeah, as our feature set grows, we add more and more modules. And so now with dynamic modules, what we're essentially able to do is turn those features on and off for different customers. So some customers might want blocking, some might not want that, some might want to block on IP, different things. With dynamic modules, it allows us to really load what we want to actually turn on and off for that environment and to save resources. Builds. So let's first talk about what our build process looks like, and then kind of walk through how we changed it when we started doing dynamic modules as opposed to static modules within it. So this is what our CI environment looks like. Most of our processes, normally we go build, package, test, and then deploy. We build largely with Jenkins. All of our packaging goes into just Debian packages and then into an apply server. We test using custom harnesses that we wrote that basically test all the functionality and features within our application. And then finally, we deploy it out with Chef to our network and all of our production machines. So before, let's talk about how static built modules are normally built. During the configure process step within NGINX build, you generally include all the modules that you want to go through. If they're part of the standard module set, it's just a -- with or -- without if you want to not include it or include it. And then you also have the -- add module for any external module that you're adding into your specific build. And all that occurs, again, in the configure step when it's getting ready to build you your makefile. So our initial build strategy, when we first started this exercise, and largely how we do it still, only it changed somewhat slightly with dynamic modules, is we pull down all the source, grab all of our external modules, everything like that. We then spin up Docker containers on our build server, and then do the compile within those. So that allows us to hit different types of OS, different kernels, and test that. And then again, benefits there is just fresh environment, and then we don't also have to maintain a whole bunch of slave machines within our Jenkins environment. Like I said, compile goes into the container, and then we go into the packaging step. One interesting thing that we do, showing in these screenshots over here, is on each build that we do, post going and doing the compilation, we go and we actually package everything into tars and make a catalog that the developers can then go back and reference or pull down any specific build that we did out there on the network. So then if we're seeing a problem or bug, they can go back and reference that specific one for an environment, go and see exactly what's going on, pull it down very quickly, and look at the code. And then this top portion is really just showing, this is essentially what all of our builds look like. We have 2 scripts, very streamlined. The first one is just doing all of the make, the compile, setting all of our configure options, and that publish is specifically building that up into that catalog. And then finally after that, we go into the packaging step, which is doing your normal Debian build, and then finally repeat as needed. So this worked pretty good for a while. So some of the problems that we started to see over time, and you will in a build environment, was using the old way of static modules, is as you're adding more and more of these modules, your compile time's increasing. So that was one thing. So it was starting to take a long time to do individual builds. Pushing this out to integration multiple times a day, just a lot of wasted cycles that were very hard. That we were losing there. Then the other thing too was versioning changes. I'm very, very big on versioning. It's one of my, it's kind of one of my passions, and I really didn't like the fact that it was hard to. So I'm very big on a system seeing Debian packages and being able to go and reference immediately what the version is when I go and look at a system for everything that's running on there. And with these being built into the actual binary, I found it very hard to go and quickly reference what version of this we're running. Is it the same here? What's causing this problem? Some of the ways we're trying to handle it, we do it in a pre-built script, and it's easy to go and look at the script that's currently there, but it doesn't give you really insight into the environment unless you go. You can do NGINX -v, but it's just all right. And then also we tried submodules on that. But again, that was just another thing that was very much, I didn't particularly like about the entirety of the process. So let's look and see how dynamic modules help with that. So first, we'll walk through dynamic module builds. So when you're going to make a module dynamic, essentially it's very similar to how you do static ones, only for the external modules, it's -- add dynamic module, and then again, the path to your module. And then for core modules, you can do any of the normal ones, like the example I use there is -- with mail, and then you just say equal dynamic to go and build the .so off of it. So the changes to the build pipeline that we did specifically for dynamic modules. So first thing we did was we separated out the binary compile from the module compile. So with the dynamic modules, there's a second step you can do that will actually make the module specifically. And then we have each module be a separate build. So this essentially allows us to do parallelization of all of our modules, which greatly reduces the compile time because we're able to compile almost all of them simultaneously. And then finally, excuse me. It allows us to rebuild individual modules. So if a developer's going and making a single change to one module, it made no sense for us to have to go and rebuild the entirety of NGINX when we already have this nice catalog of compiled binary code and everything above that for the module. So now it very much allows the developer to go, grab the code for that specific binary and build one module against it, and he's off the race to check his change for that specific NGINX module. And then finally, as I said, I love versioning. The packages, with the modules being separate from the binary, you can now package them individually and have all of those nicely referenced as well. And something you can easily see outside of the actual NGINX binary itself. Cool. So then upgrades. So after we video all these builds, now we're going to talk about our deployment piece of the operation. So upgrade paths with static modules. So as of there's 2 different ways that you can really do an upgrade with NGINX. There's an upgrade with a restart, and then your in place upgrade. Just reviewing, upgrade with a restart, of course, very straightforward. Install the new binary, go with packaging, SCP, whatever you guys use, and then you basically essentially just restart the NGINX instance. Again, this is really, really great if you can take traffic off the node, which we can't in almost the majority of our cases. So there's the nice operation of in-place upgrades for NGINX. So essentially what this is allows you to spin up a second set of processes right next to the original master and worker processes, and then switch all the connections over to them. It basically works, like I said, first step is you split up a second set of master with all the workers sitting next to it. So you have two different sets. It also makes a separate PID file for each. You spin down the first master's workers. At that point, all the client connections are passed over to the new set of workers, which are running the new binary. And then you finally kill the old master. So then at that point, you just have the new workers, the new master, all running the new binary that you deployed out there. So we do this quite a bit, and some of the things that we started to find was some interesting edge cases or ways that this in-place upgrade would actually fail for us. And just talking through some of the safety checks that we actually put into our specific the automation that we wrote around this to go and look for. So one of the things that we had happen on a few occasions was that second set of workers that were spun up, there was not actually enough memory for them to consume, so a lot of them would die. So the first check we put in was verifying that there's enough memory available for both sets of workers to be in place and on at the same time during that period when they're both up. The second check we do is we also reload our configurations at periodic times. So we were checked to make sure that an upgrade from our deployment wasn't actually occurring at the same time that the configuration was being reloaded, and then we're also stopping that process during the in-place upgrade in order to make sure that that can't kick off in the middle of the upgrade. So it stops that process, does the upgrade, and then turns it back on at the end. Checks the path of the running master binary, which is important. So if you're if for whatever reason, we do all of our NGINX start and stops through upstart scripts, and if for whatever reason a support engineer goes in there and stops NGINX or starts it with just using the binary, it can sometimes cause the path that's shown during the in-place upgrade to be incorrect and then cause it to fail again. So we always check that too to make sure there's no, nothing's been started incorrectly or stopped incorrectly on the machine. And then finally, we check to make sure all the old worker processes were shut down correctly and passed their connections over before we kill that old master. As I said, NGINX does that by default, but we still do a redundant check in there just because it's, again, concerning to us. So the way our automation around this actually works is we wrote a custom resource within Chef that does, and if anyone uses Chef or is interested in seeing this, we have it all available for anyone that would like to consume. But it automates all those safety checks through Chef. It's very easy to use, as you see there. And then we have a nice memory override in there for environments that if the customer is taking traffic off or something and we need to override the memory for that could have that edge case, we can do that. We don't really use that very often, but we just put it in there as a, like I said, an override. But anyways, yeah. So some of the problems that we saw with this in-place upgrade, again, it's very dangerous in my opinion. Each time we do it, I don't really like ripping out a binary in the middle of any time when traffic's running through it, so it kind of makes me pretty scared. It was slow. With all the safety checks in there, sometimes the process could take a few minutes, and I mean, when you're doing hundreds of machines, that adds up again over time. And then finally, it's extremely inefficient. Replacing the entire binary when sometimes you're pushing a few bug fixes to an individual module is not particularly, again, it's inefficient. So let's talk about how dynamic modules helped us change this around for us some. Again, configuration changes. This is essentially just showing you how you load these dynamic modules, as you've probably seen. There's just the new directive, load module, then load module, name of the module. And then after this, it's a simple configuration reload to go and have it pick up that new module file. So this allowed us to change a lot. So our dynamic module automation now is, we just, as I said, install the package, tell it what module we want to install in the box, have it regen the template for the NGINX configuration dynamically, and within Chef, so it's just rebuilding like the nginx.com file on that. And then finally, we're just doing the reload at the end there for it to pick up that new module file. Much simpler, a lot easier to use. Yeah. So individual summary here at the end. A couple things from overall just the entire process of doing this. Deployment risk and complexity greatly reduced, as I showed there. Our overall build times, again, very much reduced. And then we save on resources at the end of the day. So it meets when doing this, it's met most of the overall operational concerns that I had around this original process and helped alleviate them. Does anyone have any questions or anything they'd like to talk about? Cool. Oh, yeah.
I guess when you're doing your dynamic
Yeah.
And have you experienced any problems with memory leak?
Yes, we have actually. So that's the next problem that uncovered. So like post doing this and having these binaries stay up a much longer period of time. So I mean, some of it gets cleaned up when you're doing it on those reloads. So that was an interesting thing when we were when we were first doing those configuration reloads on a periodic time basis. We weren't seeing those memory leaks nearly as much, and then we started doing it only when changes were occurring, and some clients weren't changing them from a number of days. So not only were we not restarting the instances, we were also not reloading the instance at all to clean up some of that memory that might have been wasted. So yeah, then we did start seeing like these drastic like increases in memory utilization there. So then we also had to go and debug where our memory leaks were at. So yeah, we did actually have that problem. Cool. Anyone else? Yeah.
So what does it do to your machines when you talk before about moving your master over to your working threads? So if you have an active connection, someone's downloading a large file or something like that. How does that work when you're moving over from master to worker?
Yeah, so you'll see, like I said, that's another thing you'll see too, is like as it, like when it's shutting down those old and waiting for those connections, it's waiting for those to close before it passes over anything actively going on. So that's why I was saying sometimes you'll see it take a lot longer when it's waiting for all of that to close out, which is again why we started moving to this direction, because of that like increased time that we were seeing on some deployments. I mean, very, very busy servers too. It was taking a pretty long time with the number of connections that had to close and be moved around. Yeah.
Do reloads also work new workers, or does it actually reload the configuration in the worker?
Sorry, that's on the reload or the the in place upgrade. You're talking like when you do like NGINX like -s reload, right? So it forks them and then spins up the new set, and then yeah, same. It's pretty much the same thing. Yeah, it spins up a new set whenever you do the reload. It doesn't. Yeah, it's a new set. Yeah.
Will we update dynamic module? We will insert some new configuration or change some configuration. How NGINX deal with this configuration update?
Sorry, one more time.
We update dynamic module.
Mm-hmm.
NGINX runs.
Yeah.
And the new module compared with old module, we fix some configurations
Mm-hmm.
or insert new configurations. So how NGINX deal with the configuration update?
So it's essentially like, so when you replace that module file, it's grabbing those new ones that you push on there. So like when we go like each time, whenever we make changes or anything like them in the dynamic module specifically. So are you talking about the configuration that's used to generate the dynamic module, or the configuration on the NGINX side that's calling the module?
In the dynamic module.
Oh, okay, in the module itself? Yeah, so we're actually recompiling those each time, like when we do any of those kind of changes, and then we just replace the .so out at the edge during the, we replace the .so out at the edge whenever we do those upgrades now, and do the reload of the configuration there.
So it will reload all the configurations and replace the old one.
Sorry?
So NGINX will reload the new configuration files.
Yes.
And replace the old one.
So there's the configuration file that's actually used to create the dynamic module. That's like the one that's specifying like, here's that you want this to be dynamic. And then there's the like configuration files at the edge that say, I want to use this module. So if it's the ones at the edge, we re-render that file to go and call the new module. Does that make sense? Okay. Does anyone have any other questions? No? All right, thanks guys.